Diyos. Maraming salamat po sa buhay at lakas na aming taglay, sa liwanag ng kaisipan at sa pagkakataong maipagpatuloy ang pag-aaral ng mga kabataan. Gabayan mo po ang bawat isa sa amin. Anuman ang bahagi na aming gagampanan, naway maging maayos at matagumpay ang pagtuturo at pag-aaral na aming gagawin sa araw na ito. Patawarin mo po kami sa aming mga pagkukulang at pagkakasala. At sa aming paggawa, ikaw po ang aming makasama. Amen.
Ang bayan ko'y tanging ikaw, Pilipinas kong mahal, ang puso ko at buhay man sa iyo'y ibibigay. Tungkulin kong gagampanan na lagi kang paglingkuran, ang laya mo'y papantayan, Pilipinas kong hirang. Ang bayan ko'y tanging ikaw, Pilipinas kong mahal, ang puso ko at buhay man sa iyo'y ibibigay. Tungkulin kong gagampanan na lagi kang paglingkuran, ang laya mo'y babantayan, Pilipinas kong hirang. Ang laya mo'y babantayan, Pilipinas kong hirang.
Great morning, senior high school students of Valenzuela City. Welcome to Valenzuela Live, Facebook live streaming in Statistics and Probability. I am glad to be with you again. Come and join me in today's session as we explore the key concepts of random variables and probability distributions. Are you ready? Let's start. At the end of this session, you are expected to meet our today's objectives, which are: letter A, illustrates a random variable, discrete and continuous. Letter B, distinguish between a discrete and random variables. Letter C, find the possible values of random variables. Letter D, illustrate a probability distribution for a discrete random variable and its properties. To warm up our today's lesson, let us have this activity entitled Countable or Measurable. Determine whether the given statements is countable or measurable. Use a heart sign if your answer is countable, a like sign if your answer is measurable. Key your answer in the comment box below. I'll give you 10 seconds, to key your answer. Are you ready? Let's start. Number 1, height of the tallest man ever living. 10 seconds, go. Time's up. If your answer is a like sign, then you are correct, since the height of a person represents is a continuous scale. Number 2, number of garbage truck used in order to clean up a driveway. 10 seconds, go. Time's up. If your answer is a love sign, then you are correct, since a garbage truck is tangible and it is countable. Let's have question number 3. Volume of water during the Yolanda. 10 seconds. Go. Time's up. If your answer is a like sign, then you are correct, since the volume of water represents a continuous scale and it varies in different areas. Let's have number 4. The time required to deliver the vaccine in the storage facilities. 10 seconds. Go. Time's up. If your answer is a like sign, then you are correct, since the time represents a continuous scale and it also varies in different time zones. Okay, let's start. Number 5. Number of chairs in a classroom in a new normal setup. 10 seconds. Go. Time's up. If your answer is a love sign, again, you are correct, since the chair is tangible and it is countable. I think you're ready to explore random variable. Random variable is a numerical description of an outcome of a statistical experiment, and it also a set of possible values from a random experiment. Essentially, a variable usually denotes as x and any capital letter of an alphabet because its value is not constant. And lastly, assumes different values due to chance, and also it is called a stochastic variable. A stochastic variable, these are variables described informally as a variable whose values depend on an outcome of a random phenomenon. Grade 11, can you still follow? Okay. There are 2 types of random variables. These are discrete and continuous random variable. Recalling the previous activity, we can group them. The number of garbage truck and the number of chairs are examples of discrete random variable, while the height of the tallest man and the time required to deliver a vaccine and the volume of water are examples of continuous random variable. So we can say that discrete random variable are the outcomes obtained from a counting process, while the continuous random variable are the outcomes obtained from a measurement. Let us distinguish the difference between the 2 types. Discrete random variable are outcomes obtained from a counting process. Mostly, discrete random variable represents count data, such as number of soda cans, number of chairs, number of students in a class, while in continuous random variable as an outcome obtained from a measurement. Often, continuous random variable represent measured data, such as height, weight, volume of water, amount of solution in an alcohol, and the time required to run a mile. These are the examples of discrete random variable. Number 1, the number of cars sold by a car dealer in 1 month. Number 2, the number of students who were protesting the tuition fee increase last semester. Number 3, the number of applicants who have applied for a vacant position at a company. And lastly, number 4, the number of typographical errors in a rough draft of a book. And these are the examples of continuous random variable. Number 1, the length of time it takes truck drivers to go from Tawi-Tawi to Davao. Number 2, the depth of drilling to find oil. Number 3, the weight of a truck in a truck weighing station. Number 4, the amount of water in a 12-ounce bottle. This time, let us deal on how to find the possible values of a random variable. Finding possible values of a random variable. Let's have example number 1. Suppose 2 coins are tossed. Let y be the random variable representing the number of heads that occur. Find the values of the random variable y. Let's have the solution. For the illustration, the possible outcome for the first toss will be head and tail. And for the second toss, for head, there are 2 choices, which are head and tail. And if in the first coin, the tail occur, these are the choices, head and tail again. Our task is to find the possible outcome and values of a random variable, which is the number of heads. Okay, let's start. Using a tree diagram, the first pair will be head and head. So the number of heads will be 2. The next pair will be head and tail. So head and tail, the number of heads will be 1. And for the next part will be tail and head. So the number of head will be still 1. And lastly, tail and tail, so the number of head will be 0. So therefore, using the values of random variable, so the possible values of a random variable range space y are 0, 1, and 2. Can you still follow? Let's start. Find the possible values of a random variable. Number 2. Nestor conducted an experiment and tested 3 televisions at random. He wants to find out the number of defective television that occur. Thus, to each outcome in a sample space, he assigned the following values 0, 1, 2, and 3. If there is no defective television, he assigned number 0. If there is 1 defective television, he assigned number 1. And if there are 2 defective televisions, he assigned 2. And if there are 3 defective television, he assigned 3. The number of the defective television is a random variable. For the illustration, let D represent the defective television and N represent the non-defective television. If we let X be the random variable representing the number of defective television, can you show the values of random variable X? Using a tree diagram, let's have this illustration. In the first test, we have the choices non-defective and defective. In the second test, each choices from the first test will have non-defective and defective choices. And on the third test, same thing. Wherein in the second test, the non-defective and defective television will have 2 choices again, the non-defective and defective television. Our task is to find the values of random variable y, which is the number of defective television. Following the tree diagram, we have the following possible outcomes. Values of random variables y, which is the number of defective televisions, are, following the column of the defective television, we have 0, 1, 1, 2, 1, 2, 2, and 3. So the possible values of a random variable range space y are 0, 1, 2, and 3. Let us proceed to the examples of continuous random variable. Suppose a motorcycle conducted to determine the distance that a certain type of motorcycle will travel using 3 liters of gasoline over prescribed test scores. If distance d is a random variable, then we have an infinite number of distance that cannot be equated to the number of whole number. This is an example of a continuous random variable because the distance that a motorcycle will cover will depend on the type of the road, the weight of the driver, and the driving skills of the driver. This time, let's deal on a probability distribution. Probability distribution is a function that describes the likelihood of obtaining the possible values that a random variable can assume. In other words, the value of a variable vary based on the underlying probability distribution. Suppose you draw a random sample and measure the heights of the subjects. As you measure heights, you can create a distribution of heights. This type of distribution is useful when you need to know which outcome are most likely, the spread of potential values, and the likelihood of different results. Just like the current issue right now, wherein the number of infected and the number of deaths are very evident. And now, let's discuss the general properties of probability distribution. Probability distribution indicate the likelihood of an event or an outcome. Statisticians use the following notations to describe probabilities. P of x is the likelihood that random variable takes a specific value of x. The following properties are observed given that P sub I are the individual properties for each value of x of I of the random variable. Number 1, each probability for a particular value or range of values must be between 0 and 1. In symbol, P of x is greater than 0 or greater than or equal to 0 but less than or equal to 1. Number 2, the sum of all probabilities for all possible values must be equal to 1. In symbol, the summation of P of x is equal to 1. Let's have example number 1. Suppose 2 coins are tossed. Let y be the random variable representing the number of tails that occur. Find the values of the random variable y. Let's have the solution. The sample space using the tree diagram, we come up with HH, HT, TH, and TT. The range space is a set of 0, 1, and 2. In finding P of y, we have these 3 columns, consisting the fraction form and the decimal form. P of 0 will have 1 over 4 in fraction form, while in the decimal form will be 0.25. P of 1 will be 2 over 4, which will be equal to 1/4, and it is also equal to 0.5. And P of 2, which is equal to 1/4, meaning 1 out of 4 from the sample space, which is equal to 0.25. Therefore, the value of the random variable y will be 0.25, 0.5, and 0.25. Grade 11, can you still follow? Let's have question number 2. In example number 2, there are 3 coins are tossed. And the random variable h gives the number of heads. Find the value of the random variable h. And for the solution, the sample space using a tree diagram, we come up with HHH, HHT, HTH, HTT, THH, THT, TTH, and TTT. The range space is a set of 0, 1, 2, and 3 number of heads. As you go through with this problem, we come up with the following table. P of 0 is equal to 1 out of 8, which is equal to 0.125. And P of 1 will be 3 out of 8, meaning there are 3 tails out of 8 from the sample space. So we have 0.35. And P of 2 will be still 3 out of 8, which is equal to 0.035. And lastly, P of 3 is equal to 1 over 8, which is in decimal form is equal to 0.125. Therefore, the value of the random variables A are 0.125, 0.375, 0.375, and lastly, 0.125. Grade 11, can you still follow? Okay. Let's have the application of discrete probability distribution. If an inventor has 5 stocks that she follows each day, the random variable being studied is Y. Based on the table below, what is the value of P of 0? Using the tables, you can see Y is equal to 0, 1, 2, 3, 4, 5, and P of I, there is missing under the number 0. And for the solution, since the sum of all the individual probability in the distribution is equal to 1, using the number 2 property, then P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5 is equal to 1. Substituting the value of each P of Y, we have P of 0, since that is unknown, plus 0.27 for P of 1, plus 0.34 for P of 2, plus 0.11 for P of 3, plus 0.7 for P of 4, plus 0.02 for P of 5 is equal to 1. And as you can see, adding the following terms, we can get P of 0 plus 0.81, which is equal to 1. Using the addition property of equality, we have P of 0 is equal to 1 minus 0.81. Simplifying the right side of the equation, we have P of 0 is equal to 0.19. Therefore, the probability that the inventor has 0 stocks is 0.19. Grade 11, can you still follow? Great. Let's have example number 4. Tell whether the given values can serve as the value of the probability distribution of the following random variable x that can take on only the values 1, 2, and 3. P of 1 is equal to 0.08, P of 2 is equal to 0.12, and P of 3 is equal to 0.17. Let's have the solution. Since the sum of all the individual probabilities is in a distribution is equal to 1, so we can have P of 1 plus P of 2 plus P of 3 is equal to 1. Substituting, P of 1 is equal to 0.08, P of 2 is equal to 0.12, and P of 3 is equal to 0.17. You get the sum. The sum of the 3 probabilities will be 0.37, which is not equal to 1. Therefore, the given will not serve as a probability distribution. I think you are ready to answer the following questions based on the discussion a while ago. You can key your answer using the comment box below. Let's have number 1. You're going to identify the term being defined by each of the following statements. Number 1, it is a variable that assigns a number of values of each outcome of a random variable or random event and usually written using capital letter. I'll give you 10 seconds. Go! Time's up. The correct answer is random variable. Next, number 2. It takes on countable number of distinct values which are whole numbers such as 0, 1, 2, and 3, and so on. 10 seconds. Go! Time's up. Using the word countables, that is discrete random variable. Next, question number 3. It assumes an infinite number of possible values, including the decimal, between two counting numbers. 10 seconds. Go. Time's up. Using the word infinite and decimal, so that is continuous random variable. Question number 4. It is a statistical function that describes all possible values and likelihoods that a random variable can take within a given range. 10 seconds. Go. Time's up. Again, a statistical function, so that is probability distribution. And last question again, number 5. The sum of all the individual probabilities in the distribution. 10 seconds. Go. Time's up. So the sum of the individual probability is always equal to 1. That's it, grade 11. I am glad you made it in our last activity. Now, the floor is open to entertain the questions that you drop in the comment section. Okay, we have one question. It goes like this. From the last example, the probability is less than 1. So the conclusion is, it will not represent a probability distribution. Okay, you're correct. Question is, what if the probability is greater than 1? Does it represent a probability distribution? Okay, thank you for the question. Okay, the answer goes like this. Using property number 1, wherein the probability of an event is greater than or equal to 0, but less than or equal to 1. Meaning, the probability of an event can be 0, and in between, and also it can be equal to 1, but not greater than 1 and not less than 0. And of course, each probability, the sum of all the probabilities, must be exactly equal to 1. And if your question is the probability is greater than 1, definitely it will not represent a probability distribution. Okay, is there any other question? Okay, I think that will be for the day. And this has been your statistics and probability teacher. I'm Mr. Go, saying study hard and keep your mindset, and have a good day, and God bless.